All right, in the previous video, we learned how we can download Landsat 8 satellite imagery data from USGS website. We also learned how to make a composite single raster grid from bands 1, 2, 3, 4, all the way up to band number 7, and then extracted NDVI values from that data to represent vegetation cover. For more information, please refer to previous video. Link can be found in the descriptions. Our purpose in this lab is to become familiar with basics of image classification and change detection using Landsat 8 satellite imagery data. To avoid repetition, I've gone ahead and downloaded two scenes of Landsat for pass number 39 and row 31 from globus.usgs.gov website and made the composite images for both scenes. The scenes were selected so that cloud cover is less than 5%. Our study area is Great Salt Lake in Utah that has been shrinking in recent decades due to climate change. And we would like to estimate the area of water bodies in May 2017 and corresponding location in May 2021. That's almost 4 years time interval. Okay, so first off, let's go ahead and unzip both zip file. Right click on the tar.gz, 7-zip, and then extract here. And also this one. All right, so now .tar.gz transfer to .tar, which is larger. So we don't need these two because of this large volume. Let me remove these two files. And I just want to work with the .tar. So I need to, again, unzip these two files. So right click, 7-zip, and extract here. So this one is for the year 2017 that I am extracting. So as you can see, these are the bands for the satellite image. We had 11 bands, and band number 8 was panchromatic band. Band number 1 to 9 was for OLI, and the other one was for TIRS, band 10 and 11. So we need to do this for 2021 for May. So let me right click on that, 7-zip, and then extract here. As I don't have much space in my laptop, I'm gonna remove these two .tar files. Here are the both images for 2017 and 2021. So if you, for example, will look at this one, the MLT, so it shows you the path 39, row number 31 for the year 2017, and also for the year 2021. So path 39, row 31, which shows you the unique location of the scenes, but for different times. So we can, the purpose is that I'm going to see the changes over time. So I use the same number for pass and row for the scene. And also the cloud cover is 3% because I set the image to select the image that with less than 5% cloud cover. Here are the characteristics of each band, band 1, 2, 3, 4, all the way up to 11. So band number 1, 2, 3, 4, 5, 6, 7, 9, they are in 30 meter. Band number 8 is panchromatic band, 15 meter, and 10 and 11, they are for the TIRS sensor with 100 meter spatial resolution. So let me go ahead and add the multispectral band. So if you click on add data and then connect to folder, which is in for the downloads, I already connected to this folder. I'm gonna add this one. This one is a multispectral band for the year 2017. If you go ahead and add it into ArcMap, so sometimes it may ask you to create the pyramid, and the pyramid is only for a rapid display at different resolution. So if it asks you to create a pyramid, click yes. So it creates pyramid for each band when it loads it into ArcMap. Okay, so that one was for the year 2017. I'm gonna go ahead and add the multispectral composite image for the year 2021. So that's this one. Click on add. Again, ask you for create pyramid, yes. And all right, so here is also the image for the year 2021. So we know that 4-3-2 band combination. So if you click on this, so this one is 4-3-2-1, 5, 6, 7, 8, 4, 3, and 2 band combination is for natural representation or natural color. So if you would like to get rid of this redundant background, so if you, for example, for this one, for the year 2021, right click on that properties. And then if you go to the symbology tab, so here you need to check on display background value, because this one is background value, and how it can identify it, because the value for R0, for G0 and blue 0, red, green, and blue, if so, this means that it's total black, and we're gonna show this background, which is 000 for RGB, as no data, and then apply and OK. So you can see that it removes the redundant background. So let me right click, zoom to layer. Okay, so it removed the redundant background. So let me repeat this for 2017 as well. Okay, and another thing is, if you look at the layer properties, for doesn't matter which one. So if you look at the right click on the image properties and go to the source tab, here are some information. As you can see, it consists, so this image, which is a composite image, consists of 8 bands, band number 1 to 7, and then band number 9. So the cell size is 30. We already knew that 30 is the spatial resolution of cell size. And then if you scroll down, you can see the extended spatial reference coordinate system. The unit is 30 meter. So it's based on the meter. And then characteristics of each band: coastal, blue, green, red, coastal, blue, green, red, and so on. So as you can see, that band number 9 is here, which is 3S. It's not band number 8. So band 1, 2, 3, 4, 7, and then band number 9. So for the other one is also the same. Okay, so before beginning the analysis, let's visually investigate both images. So this is the image that we see with naked eyes, as it is 4-3-2 band combination or natural color, red, green, and blue. However, it's not always easy to distinguish different features of landscape based on natural color representation. So we should choose data from other wavelengths. For example, 5, 4, and 3. So this representation is very useful for, which is sometimes is called color infrared band combination. Near infrared red and green is very useful for analyzing vegetation. Okay, so areas in bright vegetation, it shows better vegetation or healthy vegetation, and areas that are in the dark color, so it represents water in the 5-4-3 band combination. And also you can change this for this one as well, 5, 4, and 3. So I'm gonna compare these two image for 2021 and 2017. But to better see the changes, let's right click on this gray space and then select effects. We're going to use swipe layer tool, and this interesting tool allows you to use the pointer to swipe the map or to swipe the image from top to bottom. And as you swipe, the top layer will be temporarily erased relative to the position of the pointer. So you can see what is going on under that layer. So which layer you want to swipe? So I'm going to swipe layer 2017. And I'm also going to move the layer 2017 to top here. And after that, if you click swipe here, click on this icon. And as you can see, it says click and drag to reveal what is under the chosen layer. Okay, so if you click on this icon, and then an arrow will appear. And if you click here, and then hold the left mouse button to drag the arrow from top to bottom, you can see what is going on behind this layer. Okay, so it swipes the top layer. So, and you can see what is going on underneath this layer. So this one that I'm swiping is for the year 2017, and you can clearly see that the amounts of water with dark color or dark black color has shrinked from 2017 to 2021. So the bottom one is 2021, and you can see that the amount of water has significantly decreased. You can also move this arrow from left to right and see what is going on underneath the 2017 and also from right to left. So it's an interesting tool for the purpose of visual comparison. But my study area is not the entire scene. I'm just going to focus on specific part in this study area. So if you click on add data and then select AOI, so this is my study area. So let me click on this icon, make it hollow, outline color, for example, blue, and increase outline width. So I'm going to focus on only in this study area. So I'm going to clip this image with this area of interest. So let me search here, clip, and I'm going to use clip data management to clip both rasters, clip and clip data management. So my input, first I'm going to clip this with the year 2017. Okay, so the input's gonna be 2017 May, and the output extent is gonna be area of interest, and use this feature for clipping geometry. For the sake of simplicity, I'm gonna call this 2017. Okay, and then maintain clipping extent and then okay. Okay, so this process may take a couple of minutes, and after that you also need to clip the data for 2021. So clip the entire scene of 2021 with the AOI. So here I'm gonna select 2021, this one, and then I'm gonna clip that with area of interest. I'm gonna call this 2021. And then maintain clipping extent and then okay. All right, so let me remove this the entire scene for 2021 and 2017, and I'm just gonna focus on this area. So this is my study area. So 2017, let me move it on top, and 2021, and then 2017 here, and then I use the swipe tool so I can see what is going on, how the water has changed from 2017 to 2021. Okay, so the next step is that I have to classify this image, both image. But what is image classification? Image classification is the process of assigning land cover classes to each pixel of satellite image. So after classification, you can, for example, say, so this pixel is water, this pixel is residential area, this pixel is forest, this pixel is bare land, and so on. So, and after classification, after we're done with classification, we can go ahead and measure the area of forest, the area of water, soil, shrubland, and determine whether it was shrinking or expanding and by what percentage. The importance is land cover change is responsible for some local and global effects such as biodiversity loss and its effect on human health, such as the outbreak of emerging infectious diseases. So there are three, in general, we have three different types of classification techniques in remote sensing: supervised classification, unsupervised classification, and object-based classification. But supervised and unsupervised are the most commonly used classification techniques, and object-based classification is useful for high-resolution data. So unsupervised classification is the most basic type of classification. You just need to specify the number of clusters or classes that you want, and then computer will automatically group pixels into classes with similar spectral characters. And in this technique, training sample is not required, but after classification, user may need to group pixels with common characteristics. And for supervised classification, it is based on the idea that a user selects sample pixels from that image that represent a specific type of land cover, and which are called training samples. So human plays an important role in supervised classification. And we use as these training samples to guide the computer to identify areas with similar spectral characters to these samples. So unsupervised classification is much quicker and less expensive and is used when you don't know the study area very well. So in this lab, we're going to keep it very simple and use unsupervised classification. So in ArcMap environments, so customize extension, check on a spatial analyst, and then close. And after that, right click on this gray area and then select image classification. So image classification, I'm gonna classify the image. So we have unsupervised classification, which is ISO cluster unsupervised classification, and maximum likelihood classification is a supervised classification, which is based on the training sample. This one is automatic. You just need to specify the number of the groups or classes that you want. So I'm gonna use the ISO cluster supervised classification, but first for 2017. And let me click on ISO cluster unsupervised classification. So I am going to have only two classes. I'm not gonna make it very complex because our purpose is just to become familiar what is classification. So I just want to have two classes, water and not water, or land. Okay. So I just select two. If there was some issues, I can increase the number of the classes. I'm not interested in finding the vegetation cover or type of vegetation cover from this image. This is not our purpose of this lab, but it is possible to do that using the classification technique. So I'm gonna call this LC or land cover for the year 2017 and keep everything as default and then click OK. So as you can see, so it classified my study area into two classes, but if I compare this with the year 2017, so here we're water, right? So let me change this to 5, 5, 4, 3. So here is water, and here are, I think they are mountains, so these are bare lands. So, but here it says that, so it's like water and the bare land as one class. So this is not true. So let me increase the number of the classes. Let me repeat this again. ISO cluster, and I'm gonna use, for example, 3 classes. I'm gonna call this LC2, so 2017, and then click OK. All right, so this one looks much better. Why? Because so this one, this bright gray area is definitely water. So let me compare it with 2017, right? So these are water, 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 right? So it did a good job in finding water, and I'm gonna combine anything that is not water into one class. So 1 is water, 2 and 3 are just, I'm just gonna call it land, okay? So let me reclassify this image and reclassify spatial analyst. So 1 for the LC2 for this one. So I'm gonna call 1 is 1, but 2 and 3, both of them are the same, okay? So I'm gonna call this as 0. So 0 means it's land. Okay, and then so this is going to be LC 3 2017, LC 2017, and then change missing value to no data, and then okay. Okay, so 0 means land and 1 means water. Okay, so if you want to remove the other one, the previous one from folder connection, here you can, for example, LC2 can remove it, or LC 2017. So I'm gonna remove it from here, yes, and also LC2. So this one is LC Landcover 2017. Okay, so Landcover 2017. Okay, so this is the final one. So that distinguish the water from land. And I have to repeat this for the 2021. So for 2020, oh, sorry, not for the effect. For 2021 here, classify ISO cluster. So I'm gonna select the 2021, it's here into 2 classes. and I'm going to call this LC Landcover 2021, and then click OK. Okay, so for 2021, let me compare it with 2021. So it seems like for 2021, it did a very good job in identifying the water and distinguishing water from other that are not water. So so I'm gonna accept this one for the Landcover 2021. So this one was water. If you go to the properties, symbology, so this one, the label is water, and I'm gonna just call this land. Okay, so it's vegetation, bare land, anything else that is not water. I'm gonna call this land. And for this one, 0 was 1 is water, right? So I'm gonna use the same symbology. So 0 is 1 is water, right? So here is water and here is land. So for water, I'm gonna just use the color of this one, blue. For water. And for land, I'm gonna use which one? This one. Okay, electron volts. Land. Okay, so let me check again. So 2021 water, land, and 2017 water and land. So the next step is that I'm going to measure the area of water and measure the area of land, okay, for both 2017 and 2021. So for 2017, this one, if you right click on that, open attribute table, here you can see how many pixels are, so this 0 is land and this one is water. So how many pixels are water, right? So how can I do that? So first of all, I'm going to add a field. I'm going to call this area. And it's based on double number, and then okay. So what is the area? So each pixel, so if you right click on that properties, so for the source tab, each pixel is 30, right? 30 by 30. And the unit is meter. So it's 30 by 30 is the area for 1 pixel. And then multiplied by the count gives you the area for the entire water or entire land, okay? So right click on here, field calculator. So here, if I type 30 times count, so it gives me the area, right? So it's gonna be based on a square meter, so that's why it's very large. So I'm gonna convert this to a square kilometer. So instead of this one, I'm gonna type 0.03, so it's gonna be kilometer. Okay, and the result's going to be a square kilometer. So here is going to be the area of the square kilometer for the water, which is 3018 square kilometer for water for the year 2017. So I'm going to repeat this process for 2021 as well. Open attribute table, add another field. I'm going to call this area, and with the type of double. And then I'm gonna use field calculator. I'm gonna calculate it based on the kilometer. So that's the pixel size in kilometer, and multiply by the count gives me the total area. Okay. So for this one, the water, which is 0, right? This one. When I click that, it highlights. So it's now 2,397. Okay. So the area has shrinked from 3018 to 2000, so this one, to 2397. So if you do the calculation, 3018.45 minus 2397.66, so the area reduced by 620 kilometer, the area of water. And if you divide it by 3018.44, so it shows you how much, what was the percentage. So the percentage of the reduction was 20%. So the area of water has reduced by 20% in this study region. Okay, so this technique can also be applied to other scenarios. For example, in a study region, how vegetation cover has changed over 4 years, or if there was a wildfire in area, how what was the amount of areas that have been burnt out before, after tornado, before, after flood, or other natural disaster like landslide, how much of area have been impacted, okay, by the disaster. So our purpose in this lab was just to introduce you image classification and land cover change. And we just used the most basic type of classification technique, and we didn't evaluate the accuracy of the classification. But in real project, it would be very helpful to use both supervised classification and unsupervised classification, and also field visit to validate the result, because there are always error in classification techniques that we need to keep it that at the minimum level. So what you should do at the end is that if you go to the layout view, for example, and then here it's gonna be, so let me insert a data frame. So this one is going to be for 2021, and this one is going to be for 2017. So I'm going to move this here, uncheck this one, 2017, and I'm going to add the AOI here as well. So I will have two maps. So the first map is for this one for 2017, which you can see that it's highlighted. It's been highlighted, and also this one. So let me use the guideline. Remove this. Okay. So that's for 2017, and this one it is for 2021. And I'm gonna move it here. Okay, and then click on full extent here, and then full extent here. So insert a text. So I'm gonna call this 2017, and for example, font size. So this one was for 2017. Insert text. 2021. Apply. So it's 24, right? Okay, apply. Okay, so that's for 2021. So I'm gonna insert a legend. So just one of them, because I use the same legend, just one of them is enough. So AOI, area of interest. Probably I don't need the AOI. I just need this land cover finish. So legend, water, and then, so let me remove this border, frame, border, none. Okay, so this is the legend. I can also add the scale bar, insert the scale bar. And what else? I can insert the north arrow. And you can also add your information, your name and the date. So finally, I'm gonna add a title, insert title. I'm gonna call this water bodies change grade Salt Lake City. I can also remove the frame for this one. And finally, just add your name and also the date, and then file, export it as an image.